So here it says that a stone of weight 5.29 is launched vertically from ground level with an initial speed of 20 meter per second. So it's launched there, it goes up and it reaches a maximum height, then it comes down. And what else is given is there is an air drag which is 0.265 Newton throughout the flight. So when the stone is thrown, if there was no air drag, what would have happened is when it reaches the maximum height, all its kinetic energy with which it is thrown would be converted into potential energy when it reaches there, when it reaches at a height of h. So that would be mgh. So half mv square, which is the initial kinetic energy, would be converted fully into potential energy uh, at that point. And then the potential energy again, the stone is again coming down after that, and the potential energy is slowly converting into kinetic energy, and towards the end it would be again the same kinetic energy here. So that's there. But because of the air drag, what happens is when the stone is thrown, it has to work for the potential to gain that potential energy, as well as work against the air drag. So it will have to supply the energy due to air drag, which will be the air drag force is given. So force times distance, whatever distance it travels. So air drag will be Fa. The energy corresponding to air drag will be Fa times h being the height at which the stone uh, reaches, and that's what we need to find out. So when we do that here, plug in the values there. Half m is 5.29, that's weight over 9.8, then 20 square, and here again that is 5.29 mgh times, so mg is 5.29, so I'm just writing directly, and then equals to, sorry, that would be plus 0.265 times h. So once I do that, what I got here is 107.96 and then 5.56 times h. So h became 107.96 divided by 5.56, which I got is 19.43 meters. So that's the height at which the stone will reach. This is the first part of the question. The second part is its speed just before it hits the ground. So again, if there was no air drag, we would know what is the speed. That would be the initial speed when it reaches back. So all this kinetic energy is converted into potential energy here, and then again this potential energy converted back to uh, the same kinetic energy with which it started. But because of the air drag, it won't be the case. So again, the potential energy with which it's starting to coming down, and convert that the potential energy is converted into kinetic energy, the potential energy again will have to supply for the air drag. So again this one will be now equal to the kinetic energy, the final kinetic energy, when the whole of the potential energy is converted into the final kinetic energy square, sorry, plus the air energy due to air drag again, which is Fa being the force due to air drag, times h. And now we know what is h, we know Fa, that was given anyway. So what is unknown here is just Vf. So mgh is 5.29 times 19.43. We found that out. And then this is half 5.29 over 9.8 m times Vf square. Vf is the final velocity when it hits the ground, and then plus 0.265 times 19.43. So that's air drag, energy due to air drag. This is Fa and this is the height basically. So that's there. Now once I rearrange, what I got there is I have written this one like that: 5.29 9.8 Vf square equals to, that one becomes so this one became 5.15, and when that is taken on the other side, what I got finally is 97.63. So Vf became Vf square became 2 into 9.8 into 97.63 divided by 5.29. So VF would be the square root of that, square root of this thing, and what I got there finally is 19 meter per second. So that was the final velocity with which it hits the ground.